Hi everyone, welcome to our maths lesson for today. I am back in the classroom and back ready to get started. So, I hope you all have fun in the snow, by the way. Some of you have been uploading pictures of you building snowmen or out sledding. If you have any pictures, please send them in on Seesaw. We do like to see them. Especially I saw one where someone fell over and I found that quite funny. So thank you very much. You know who you are. Right, today's maths lesson we are carrying on looking at the area of triangles. Now, last lesson, you looked at the area of right-angled triangles. Now, to find the area of a right-angled triangle, which looks something like this, you would do length times, we'll call it the height or the width, it doesn't really matter. Length times height divided by 2. The reason we divide it by 2 is because if we do length times height, we end up with the area of all of this. We don't want all of that because we're only dealing with the triangle. So we halve it because the right angled triangle is half of the rectangle. So, area of a right angled triangle, length times height divided by 2. Today, we're going to be looking at the area of all triangles, whether it's a right angle triangle, an isosceles, scalene, equilateral, etc. So, before we get started with that, here's your starter. Now, I said start quite a lot in that sentence, I've just realised. Anyway, some of you will be familiar with this, hopefully all of you are. This is our Tough 10. My group certainly know this. Basically the way it works is you have 10 questions and you have to try and answer them in 5 minutes. So what I'd like you to do now is you're going to pause the video, set yourself a timer for 5 minutes, have a go at answering them, okay? And then I'll go through the answers with you. Off you go. Oh, that's a very quick 5 minutes for me. It probably was not as quick for you. So, starting at the top, let's work our way through. So, first one, nice and easy. 7 times 8 is 56. We need our times tables for that. Next one, 308 divided by 4. Well, I'm going to do that bus stop. So we do 4 into 308. 4 into 3 doesn't go, so we do 4 into 30. 4 into 30, well, 4 times 7 is 28. So we put that there. We carry the 2. And 4 times 7 is 28. So the answer is 77. Next one, 11 with the little 2. Well, that means squared, which means we have to do 11 times 11, which is 121. 77 times 1,000, well, that's going to be 77,000. 5,000 times 5. Now, my group will know, I always say, what's your known fact? Well, the known fact is I know what 5 times 5 is. 5 times 5 is 25. How many times bigger is it? Well, it's 1,000 times bigger. It's got 3 extra zeros. So it's 25,000. Do your known fact, make it as big as you need to. Next one, a sixth and a third. So, we cannot add these at the moment. Why can't we add them? Because the denominators are different. What are we going to do about that? We're going to make them the same. So, luckily, 3 goes into 6. So we can make them both have a denominator of 6. We haven't changed this one. How do we get from 3 to 6? We times it by 2. What we do to the bottom, we do to the top. Now we can add them together. 3 over 6. Some of you may look at that and think, I can simplify it. And you're right, it would simplify to a half. But 3 over 6 is perfectly fine. Next one, 453 times 23. So, 453 times 23. Okay. Start at the right hand side. We do 3 times 3, which is 9. Then we do 3 times 5, which is 15. So you put the 5, carry the 1. 3 times 4 is 12. Add the 1 is 13. We're moving into the next row now. It's 20. We put a placeholder. We now start here. We do 2 times 3, which is 6. 2 times 5, which is 10. Carry the 1. 2 times 4 is 8. Add the 1 is 9. And now we add them together. So we've got 9. 5 add 6 is 11. Carry the 1. 3 add the 1 is 4. 1 add 9 is 10. 10,419. Three with a little 3 next to it. The little 3 means cubed, which means you times it by itself and then you times it by itself again. So it's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Next one, 2 times 6 times 10. 2 times 6 is 12. 12 times 10 is 120. Final one here, 208 divided by 1. Any number divided by 1 is itself. So 208 divided by 1 is 208. Okay, that's your starter. You may think, oh, I found that quite tricky today. We do them each day, and as my group would say to you, it gets easier, you get quicker, you learn how to do the questions. Okay, on to the actual lesson. So, we have 2 different triangles here. We have a right-angled triangle, and we have, well, it's actually an isosceles triangle, but just looks like a regular triangle, okay? All you need to know is it's not a right-angled triangle. So, this question says, what's the same and what's different? Well, the difference is they're different types of triangles. But what's the same? Well, what's the same is that they both have the same area. And that's because when you're working out the area of any triangle, right-angled, isosceles, scalene, whatever it might be, okay, you do the same thing. To find the area of any triangle, you do length times height divided by 2. The same thing we did last lesson. So today you're going to see some different types of triangles. It doesn't matter. You do the same thing we did yesterday. Length times height divided by 2. I'm saying that a lot because I'm hoping that you've made a note of that. Area of any triangle equals length times height divided by 2. Write it down. Great, thank you. Okay. But why? Why do we do the same thing? I got it with a right-angled triangle because I could see that a right-angled triangle was half of the rectangle. But that doesn't look like half of a rectangle. That just looks like it's a part of the rectangle. Well, have a look at this. The area inside the triangle is the same as the area outside the triangle. It's just been slotted differently. The area in pink will fit into the triangle in the middle. Therefore, even though it doesn't look like it, the triangle is half of the rectangle. It's just not as easy to see. Look at this one here. Again, doesn't look like half of a rectangle, but the area outside of the triangle is the same as the area inside the triangle. Therefore, that is half of the whole thing. I'm hoping you can see that from the images. If not, you just need to know this is what you do. So if you can't see it, it's fine. I can't really show you it, unfortunately. I would if we were in, but I can't. You need to remember that length times height divided by 2 for any triangle. So this is a right angled triangle. How would I find the area? Well, I know from yesterday, I do this times this, so 3 times 10, which equals 30, and then I divide that by 2. And I put a little squared sign on it. So the answer is 15 centimetres squared, like so. What about this one? I do exactly the same thing. See if you can work it out. Pause the video, have a go at it. Okay, so hopefully you did 7. Hopefully you did 7 times 6, and then you divided it by 2. That's what I'm hoping you did. 7 times 6 divided by 2. 7 times 6 is 42. Divided by 2 is 21 centimetres squared. There you go. Length times height divided by 2. This one here, same thing. Length times height, 8 times 7 is 56. Divide that by 2 is 28. What am I going to do with this one? Exactly the same thing. 4 times 7, 28. Halve it, 14. This one here, what am I going to do? It's pink, therefore it's different. No. 5 times 8, which is 40, divided by 2 is 20. Ah, this one's orange and it looks a bit weird. No. 12 times 6 is 72. Divided by 2 is 36. They're making the numbers a bit bigger. You still do the exact same thing. Activity 1 then is I'd like you to have a go, please, at finding the area of these 3 triangles. Remember, length times height divided by 2. Off you go. Okay. First one's 15, 25, 44. Straight into activity 2. Now, this is where they start to throw something different in. Because this time, they've given us this side here. We don't need it. We need the height. Now, the height has to be in a straight line. Can't be angled. It has to be straight, which means sometimes it's drawn in the middle of the triangle. Sometimes it's drawn at the side of the triangle. And it shows us from the bottom to the top in a straight line. Remember, we do length times height. The height is there, from the bottom to the top. This bit here, we don't need it. That measures from here to here, which is great. We don't need that for the area. If we're looking at perimeter, we might use it, but we're not. We're looking at area. So the activity then says, Yasmin says the area of the triangle is 70 centimetres squared. Ahmed says the area of the triangle is 35 centimetres squared. Jamal says the area of the triangle is 45 centimetres squared. Only one of them is correct. Who? So, most of you, what I'd like you to do is work out who is correct by doing length times height divided by 2 and just put that person down. My group, I want you to work out who's correct and then tell me what the other two have done to get it wrong. Off you go. Okay. Let's start with Yasmin. Yasmin says the area of the triangle is 70. Well, I know what Yasmin's done. Yasmin did 10 times 7. Good start. Pardon me. And has stopped there. So Yasmin forgot to divide by 2. Not her. Ahmed says the area of the triangle is 35. Well, Ahmed did 10 times 7, which is 70, and then divided it by 2, which is 35 centimetres squared. So Ahmed is correct. So those of you that are just doing that, Ahmed is correct. He got it right. Jamal. Jamal says the area of the triangle is 45. What Jamal did is Jamal did the length and timesed it by that side. 10 times 9 is 90. Then he halved it, which is 45 centimetres squared. He used the wrong side. Remember, it is length times height. Base length times height, not the sloped side. Okay, this is some of the ways that they can try and throw you off. They turn the triangle around, they put a weird line, and then they put it all sorts of angles. It's no more difficult. As long as you remember length times height divided by 2. Someone keep count of how many times I'm saying this, because I feel like I'm saying it a lot. So the first one here is upside down. So what we need to do is identify the length and the height. Now, the length always goes along the bottom of the triangle. But in this case, it's upside down. So the length is always where the height meets a straight line. What we call perpendicular. It's where the height meets a straight line. So the length is 5. The height, remember, is always a straight line. So the height has to be 3. So we would do 5 times 3, which is 15. And we would then divide that by 2, which is 7.5 centimetres squared. The next one, first job, identify the length. Well, the length is the straight line. Okay, straight line sits flat. The one at the bottom, in this case. So the length is 4. The height is from the bottom to the top in a straight line. So the height is 6. So we do 4 times 6, which is 24. divided by 2 is 12 centimetres squared. Can you have a go at this one, please? Identify the length, identify the height, times them together, divide it by 2. Off you go. Okay, so the length is 10 because it's where the height meets the straight line. The height is 5 from there to there, the straight line. 10 times 5 is 50 centimetres squared. Half of that is 25 centimetres squared. There we are. Activity 3 then. Have a go at these. They've been turned on weird angles, but they're no more difficult. Can you have a go, please, at working out the area of these triangles? Off you go. Okay, let's have a look then. So the first one, the base is 14, the height is 6. Answer would be, oh, where's my answer gone? Well, it's not even giving me the answer. Fine, I'll do it for you. 14 times 6. So we do 14 times 6. Well, 6 times 10 is 60. 6 times 4 is 24. So that would be 84. Divided by 2 would be 42 centimetres squared. The second one would be 4 times 9, which is 36 centimetres squared, divided by 2 would be 18 centimetres squared. And the third one would be 12 times 8. Well, 12 times 8 is 96 centimetres squared. Half of that would be 48 centimetres squared. There we go. There we go. I like to make sure it all looks the same. Okay. That's what we've just done, really. So we're not going to worry about that. I think I went a step ahead. Oh well. Not going to worry about that one. Okay. So the final thing we're going to be looking at today is, well, what's the area of the bit outside the triangle? Well, it's the same as the bit inside the triangle, because remember, the area of this beautiful Christmas tree I've just drawn is the same as all of this. So therefore, to do it, if you wanted to find the area of this bit, you would do the same as you would to find the triangle. You would do 4 times 4, and then you would halve it. Okay? But I'm not going to worry too much about that for now. The main point of today is that you understand how to find the area of any triangle. You do that by doing length times height divided by 2. Okay. There will be an activity posted on Seesaw for you to have a go at. Okay. Thank you very much for listening. I look forward to seeing you tomorrow where we move on to something slightly different. For now, goodbye.